Hello, hello. We're going to get started in a couple minutes so give people time to join. Welcome, welcome, welcome. Hope everyone's doing fantastically today. Enjoying the hackathon. Enjoying all the goodies this hackathon has to offer, including these fantastic workshops where we're going to be going through some really cool stuff with NFTs, with IPFS, storing data in a decentralized context. So, welcome. Hello, everybody. Welcome to the stream. Welcome. We're going to give it a few minutes here. So if you're jumping in, say hi, let us know how you're doing for the hackathon. Let us know how you're enjoying the workshops. And of course, please, after this is done, please take the feedback form. And I should have it handy with me more often, huh? I should definitely have it handy with me so I can just copy paste and send it to y'all. The feedback form really helps us. It helps us figure out if these are good, if people like these workshops, if people don't like the workshops, if they're good use of time, if they're not a good use of time. Oh, I see so many people saying hello in the chat. Hello, hello. Definitely say hello, GM, even though it's 4:30 where I am right now. GM, hello, hello. Going through the staking application, learning a ton. Excellent. That is fantastic to hear. You're going to become a DeFi wizard with that one. So excellent. Staking workshop. Oh, you were there too. Excellent. Excellent, excellent. These workshops are always great. That is quite flattering. That is quite flattering. Hello, GM. It's 4:30 right now. We're gonna give it a couple more minutes here, and then we're gonna get started. And got a treat for you. I got a treat for you all because I've done so many NFT workshops at this point, and I've done so much NFT stuff. We're gonna have some choices, so we're gonna do a little bit of voting here. What do people want to see? But I'm not going to tell you what that post is, what that poll is quite yet, because again, we're going to let a few more people join, and we're going to go down the workshop NFT IPFS rabbit hole, and we're going to learn a ton. If you haven't learned, if you're not sure how to do an NFT, if you're not sure how IPFS works, or if you're just looking to see some really cool code and learn something new, you're in the right spot. You're at the right workshop. You're in the right place. Still going to be using this in this workshop. Still going to be using what? I don't know what you're referring to. Wave. Is it going to be brownie or truffle, Patrick? Oh, good question. Good question. I'll get to that. Your videos on Hardhat contract deployment were so helpful. That's great to hear. Yeah, Hardhat deploy. Super underrated. Really fantastic plugin, right? Oh, you guys are flattering me. Hello. Welcome from Argentina. NFT with royalties. I just did a review on a contract that's doing royalties are really interesting. We're not going to do that, but maybe if we have time, we probably won't have time. But if we have time, before we even start, we have a question, and then after this question, we're going to jump into it. 2 a.m. from India. Oh my goodness, beast! That is beast mode. Welcome. You are killing it. Hello from Italy. Hello, Italy. Hello from Texas. Question. Is IPFS a only solution to store data? Can we use Internet Computer to store data? I haven't worked with Internet Computer so much, so I'm unfamiliar. Maybe. I know there are other decentralized storage applications out there. One of them is Arweave. One of them is OX Chain. I did a write-up a while back. It's on the Ethereum documentation, my write-up. But there are other decentralized solutions. And tomorrow, we're actually going to show you how to store your NFT data 100% on chain, which is really cool. Of course, it's more gas expensive, but do a workshop on image generation, creating front-end dApp. Oh, Vinny, yes. We are doing some front-end content. If it's not this week, it's next week. It's somewhere on the schedule. What does NFT stand for? I'll get to that. I'm working on NFT credit. Looking forward to learning a lot. Hello from Brazil. Hello from Dubai. How can I verify these credentials using Chainlink? What credentials? Sorry, not sure the context of your question. But with that being said, we're going to get into it today. We're going to get into it. We're going to talk about NFTs. We're going to learn what an NFT is. and we're going to code an NFT, and we're going to store the NFT, and we're going to do all types of amazing NFT stuff. So before we jump into it, do a quick refresher on what an NFT is. Let me share my screen here. To nothing, just a big blob of nothing. There we go. That's better. What is an NFT? Right? What is an NFT? Well, an NFT is also known as the EIP 721, or the non-fungible token standard, which stands for NFT. Non-fungible token. NFT means non-fungible token. So what does non-fungible mean? Well, non-fungible means it's not interchangeable. So like $1 is interchangeable completely with another dollar. $2 have the exact same value, right? However, your cat doesn't maybe it's not a good idea to use cat. Your car doesn't have the same value as another car, right? Or a home is never going to have the same value as another home. Or the original Mona Lisa is never going to have the same value as another Mona Lisa. These are things that have unique value, right? They're not fungible. You can't interchange them, right? This is what non-fungible means. And to create these, to create tokens on chain, to create assets on chain, using that are like this, that are not fungible, the Ethereum community came up with EIP 721, which is the non-fungible token standard, which defines how to make tokens that are non-fungible, right? Make unique assets. And basically all an NFT is it's just a jarble of code, right? An NFT is just a smart contract that has all of these functions in here. It needs to have an owner of function, which returns the owner of a certain token ID. It has a transfer function. It has a transfer from. It has an approve function. It just has all these functions, and boom, it's considered an NFT. Okay. Now, what a lot of people are familiar with is kind of NFTs as kind of the art craze. Because yes, like an NFT is going to be a piece of art, right? So like, an NFT can be a piece of art, like this, like all this stuff here. These are all like pieces of art, because they are on chain. They have some value which defines like what they look like. Now, so NFTs are just smart contracts. They have all this stuff in here. Now, what NFTs? Now you might be thinking, okay, cool, Patrick. So NFTs are smart contracts, but how do I know that? Like when I look at, I'm picking some random NFT here. This specific NFT, how do I know it looks like this? That's kind of trippy. Why? Holy, what the heck? How do we know it looks like this? Well, NFTs come with this. Quality is a bit low. No, it's fine for me. Okay, quality is fine. All right, cool. There was the first couple of videos were 720, and that was really upsetting. Anyways, so NFTs come with this thing called a token URI, and this token URI is the key to what these NFTs look like. A token URI is a distinct uniform resource identifier, kind of like a URL basically, but it could be with any protocol. You can kind of think of it as basically a URL for a given asset. And this URL points to some JSON object that looks like this, right? The title of the asset, the type of the asset, and the properties, with one of the main ones being the image, which is going to be another URL pointing to some other image. Let me pull up IPFS real quick. Oh, whatever. I guess it's here. And excuse me. And what one of these might look like is, nope, sorry, that's not it. Where is my, come on. Where is my JSON? Oh, metadata. Here we go. I have too many files. Here we go. What one of these might look like is this, right? So this is a meta JSON object where a URL will point to this. And if I click copy the CID on IPFS, and I'll explain what this is in a little bit. I do IPFS / stick that in. We get like this URL that points to. LOL, saw that leak pop up. Yeah, I had a spurt. I play like League of Legends like maybe twice a year, and unfortunately, like a few days ago, I had an incident where I played League of Legends. It was a sad day. Anyways, I don't play video games anymore. So I posted a link to IPFS in the chat here, and this is and you might, if your browser doesn't have it compatible, don't worry about it. It might not have it. It's fine. But it points to this this object here, which defines like what the NFT looks like, and then it has this image attribute, which is another URL, which points to like what it looks like, right? And no one's believing me for the one. I swear that is like the first time I've played in literally 6 months. If I play it more often, I get addicted too easily. But so instead, I just get addicted to writing smart contract code. Anyways, so that's the image. So that's how we know what this looks like. So that's exactly what this URI points to. Now you can have this token URI. Now the question is, okay, if we just do like an HTTPS, / some URL.com. Well, guess what? Your image now is centralized. And in fact, it's kind of funny. What you can do is you can go on OpenSea. And we can check to see what the token URIs of these functions are. And we can see if they're using centralized token URIs or decentralized ones, right? Because if they're using just a centralized token URI, then guess what? If that server goes down, then the NFT is going to look like nothing. So, and I'm going to pick this random imaginary ones, and we're gonna call them out. We're going to see where are they hosting this image. Where is this image being hosted? So what we can do is we can actually go to their contract address. We can check their contract here. We'll go to read, and we'll find a token URI. We'll pick a token ID. What do we think? Put in the chat. Do we think that this imaginary ones, this random NFT that we picked, do you think that it's hosted, that this image, this NFT image is hosted on a centralized URI or a decentralized one? What do we think? Guesses in the chat. I'm going to feel terrible if I call them out and they're actually centralized. Mobile, y'all are still giving me crap for League of Legends, huh? Okay. Oh, we have some guesses. We think it's centralized. What do we think? Centralized, decentralized. What do we think? Decentralized. People use centralized URIs? How gross. Yeah. And in 10 years, they will just be broken JPEG images. So we have some guesses in the chat. It's looking pretty even, 50-50. Centralized because space. Okay. 50-50. Okay, I'm going to hit query. Let's see. Okay, non-existent token. Okay, well, let's find this one's token ID. So this is what? 1538. So we'll do 1538. And it's kind of a mix. Oh, no, this is centralized. Okay. It's being hosted at imaginaryOnes.com with an IPFS subdomain. So they have this hash, right? If we pop into IPFS, if I place this in here, let's browse. Let's look for it. Oops. Inspect. If I do, if I post their hash, we should be able to find the thing. It's like, so they posted it on IPFS, but they're hosting it on a centralized server. Almost. Well, now I feel bad for calling them out like that. Anyways, they like it looks like they wanted to be on IPFS, and then they kind of dropped the ball by doing it on a centralized server. But in any case, yeah. So you can check. Now I feel terrible. I'm sorry, imaginary ones. I didn't mean to call you out like that. Sorry. Anyways, so cool. So that's how we know. These workshops are a ton of fun, right? They're a ton of fun. So that's how we know what these actually look like. Okay. Now, we're going to build some code that is this contract here. right? It has token URI, and we're going to store this data here. We're going to store the image in a decentralized context, okay? So we're going to make sure that even if our server goes down, if we die, it's fine, right? We're going to be okay because we're going to host our data in a decentralized context using IPFS. Okay. So with that being said, are there any questions about what an NFT is, or does anyone else feel bad about how I just outs that project for putting their token URI on a centralized server? Any questions on any of that? IPFS subdomain on a centralized server. So, oh, sorry. I thought that was a real question. What defines the initial value of an NFT? Good question. And the answer to that is the value of an NFT is whatever someone is willing to pay for it. Seriously, I know that sounds like a cheap cop out of an answer, but that's really it. You know, that why does the Mona Lisa have value? Why does the Van Gogh have value? The exact same answer to that is why NFTs have value. You know, people think art has value. People think NFTs have value. NFTs are a better way to sell art and do a lot of other stuff. But one of the biggest use cases is art. That's kind of your answer. Yep, always research. Okay. How can you know that it will persist indefinitely in IPFS? Can you check if it is pinned? Amazing question, and we'll get to that actually. Really good question. We'll get to that. What's matching? Why are NFTs so popular? They're just images. Why is art so popular? Same answer. I missed it. What IPFS viewer are we using? Haven't gotten to that yet. I will. How to create the JSON metadata from images that already exist? I'll get to that. The value of anything is defined by what someone's willing to pay for it. Yes. You can pin it yourself. Yep, I'll get to all that. Don't worry. I'll get to all the coding stuff. You can also make utility of NFTs. We're doing the art here. How to create JSON metadata from images that I'll get to that. Maybe they just maybe they are gonna switch it over to like IPFS or on-chain or Filecoin or something else, but I don't know. How does data stay forever pinata? Amazing questions. I love all these questions. Let's get into it. Now, because this is live, we get to pick if we want to have this be what we want to do. We get to pick. Now, because like I said, I've done this 100 times. What do you all want to see? Put in the chat. Do you want to see a hard hat edition of this or a brownie edition of this? With the caveat that the solidity is going to be exactly the same. Okay. So if you're using Foundry, if you're using Truffle, if you're using brownie, hard hat, some other framework, all the solidity is going to be exactly the same. So you can still follow along with me. And I'm going to go a little bit quickly through the scripts because the scripts are the only thing that change based off the framework that you're using. So what do we want? Hard hat, brownie. Okay. Let me read the chat. Wow, hard hat. Okay, we have one brownie. Excellent. I'm seeing well and beyond hard hat. I'm seeing 2 brownies, 3 brownies, like 15 hard hats. 1 foundry. Leo, 1 foundry. I'm seeing someone saying hard to hada. Okay. All right. So I'm seeing well and beyond votes for hard hat. So it looks like we're going to be using a hard hat. But I want to give some shout outs here. Again, the solidity code for these is going to be all the same. So if you do want to see this in brownie or see a version of this in brownie, I'm going to post this in the chat because we're going to do hard hat just because well and beyond people were excited for hard hat here. Here's an NFT mix that I created that it's going to go through nearly exactly this. So it's going to be brownie. Follow along with me for the solidity, and then you can kind of use this as a reference for look at that. Woo, use this as a reference for working with brownie. But since so many people said hard hat, I'm going to give you all a sneak peek. So as some people know, working on a crazy blockchain solidity course for hard hat, and I'm in the middle of filming it, and so we're giving you a sneak peek on the NFT section here. Okay, so here's going to be the code that we're going to be going over here for this demo. It's this hard hat NFT FCC. Now again, this code is meant for this ultimate course that I'm creating, and it's so it's going to be very specific to that course. Okay. And this repo shows you actually 3 different types of NFTs you can create. One's a really basic one. Streaming quality is low, huh? A couple other people saying quality. Same for me, quality is dead. Oh, that's not good. Screen was low res, can't see it. Okay, well, hold on 1 second. Thank you for being so proactive and letting me know. Quality is bad. Quality is bad. Okay, hold on 1 second here. How about now? Is it better now? It's the league. Oh my god, y'all brutal. Y'all brutal. It's literally been like 6 months. Audio is perfect. Visuals are bad. Is it coming back now? Coming back now? It looks like it might have been a Wi-Fi thing. It's coming back now. Okay, cool. All right, great. Thank you all for letting me know. Anyways, back to the code screen. Yeah, keep me posted if it's good or not. Anyways, here is what we're going to be doing. This is Hard Hat NFT FCC. Like I said, this is for the free code thing that I'm doing. We have 3 types of NFTs in here. One's basic, one's dynamic, one's random. So I'm also going to give you the other option here. I'm going to give you 2 polls here. What do you want to see? Do you want to see an NFT? Actually, no, we're going to do the random IPFS NFT. I take it back. We're going to do this one. We're going to do the random IPFS NFT. It's going to give us a randomized NFT where we're going to have NFTs that are more or less rare than each other. So let's go over to our code editor. I'm already in VS Code. I have a new folder. If you haven't seen like the intro to Hard Hat, definitely watch that, or intro to Brownie, or intro to whatever. Definitely watch that before coming here. Okay, cool. Let's do it. So quick README, just to say what we're going to be building. README.md. So number 1, we want to make an NFT. Number 2, we want to have, or excuse me, an NFT collection. So anytime you deploy an NFT smart contract, it's going to be a collection of NFTs. Number 2, we want each NFT to have a rarity. That's going to be influenced by a Chainlink VRF, right? We're going to get a perfectly random number for our NFTs. So they're going to have a rarity. And yes, they're going to be random doggies, random doggies. And we're going to give rarity to each one. And we're going to have people pay to mint the random dogs, right? And you can imagine this would be something like, a game, right? Where you get a random, a random Pokemon card. You get a random Dungeons and Dragons character. You get a random, a random etc. Right? These NFTs are exactly how you would do something like that. And yes, we're going to do some random doggies. We're going to do a pug, Shiba Inu, and Saint Bernard. Pug, Shiba Inu, and a Saint Bernard. Aren't they freaking adorable? Yes, they are. And on that note, one more poll for y'all. Which dog do you want to be the most rare? The pug, Shiba Inu, or Saint Bernard? Which one should be the most rare? Which one are we going to be like, this is a super rare dog? And if you get it, you are amazing. Which dog do we want to be the rare NFT? Which doggy? Saint Bernard pug. What do we think? What do we think? Saint Bernard. 300 by 200 CRT screen. Bernard, Shiba. All right, so we're doing Saint Bernard. Saint Bernard is going to be our rare. Yeah, YouTube does need to add a poll for real. Saint Bernard is going to be our rare thing here. So let's do this. We have, I explained NFTs for about, 20 minutes here? It's time to actually do some coding. All right, so to get started, we're going to create a new Hard Hat project. Now I'm going to cheat a little bit. 1 second. Because for my setup, I love to do kind of the same setup, which is going to be this command right here. And we're just adding a ton of stuff. We're adding a ton of packages. We're adding Nomic Labs, Ethers, Hardhead Deploy, Waffle, Hardhead Contract Sizer, Hardhead Deploy, Gas Reporter, blah, 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 all this stuff. I'm going to post this in the chat. It'll get split into two things if you want to copy paste it, if you're following along. And this is going to add a ton of boilerplate for us. It's going to add a whole bunch of plugins that we're going to use. It's going to make our life really, really good. As I use these in the workshop here, I'll explain, hey, this is one of the plugins, and here's how you use it. So I posted it in the chat. It's a monstrosity. Feel free, if you're watching this later on, feel free to pause. Here's the rest of it. Or again, you can just go to the repo, grab that package JSON, and just run yarn to grab all the node modules in here. So it'll take a hot minute for us to download everything. Oh, I'm excited. I got to code kind of quick too, because I just realized I'm trying to show y'all IPFS, answer all your IPFS questions. So that's what I was going to post earlier. Thank you. I appreciate that, Mr. Alex. We're going in. I just feel so bad that I exposed that project for having a centralized token URI. Anyways, great. So we have that. We'll do yarn. Now we have access to hardhat. So we'll do yarn hardhat. Or if you're running with npm or npx, you would do npx hardhat, right? And if you wanted to install all that stuff I just gave you with yarn, you could also do npm install -- save dev, right? That's going to be the same, and then all those packages. But now we can do yarn hardhat, or again npx hardhat, and we're going to get this little output saying, hey, well, what do you want to do? And for now, let's just create an empty hardhat.config.js, right? So now we have this hardhat.config.js. We're going to change the version to 8.7, and we're off to the races. Okay, new folder, contracts. In here, new file, random IPFS nft.sol, and it's indexing. Of course, it's indexing because I have so much stuff. And let's do it. So how do we start our contract? Well, SPDX, license, identifier, MIT, Pragma, Solidity. What version are we using? 0.8.7. We'll even do a little caret here. Contract, random IPFS NFT. Boom. Pull up the terminal. Yarn hardhat compile. How we looking? Things are looking good. Compiled successfully. Okay, let's get into this bad Larry. So what do we need to do this? Well, again, if we're doing an NFT, we need all this stuff. We need all these functions. So I would need to create a function called transfer from. And what I could do is I could say, okay, function transfer from, some parameters. It's public or whatever. It does some stuff. Okay, what's the next one? Function safe transfer from. Okay, I could grab that. What does it do? Function safe transfer from. Okay, it does some stuff. Don't copy this if you're following along, right? It does some stuff. And I could write all these functions out myself, but that would be a huge pain in the butt. So I'm not going to do that. And quality is dipping again. Oh, it's my Wi-Fi keeps. Okay, 1 second. Sorry, 1 second. No, Wi-Fi. I did not say Wi-Fi. I said Wi-Fi. Hold on. Yeah, I clearly need to plug into a box instead of being on Wi-Fi here. Sorry, guys. Thanks for letting me know. I said Wi-Fi, not wife. Wi-Fi. All right, it looks like we're back now. Sorry about that. Thanks for letting me know. Happy Wi-Fi, happy life. Y'all are brutal with the League of Legends jokes. Oh my goodness. Oh, it's dropping again. Come on. All right. Well, this next part, I'm just talking anyways. So instead of us writing all those functions out ourselves, guess what we're going to do? We're going to just import from OpenZeppelin and inherit all the functions ourselves, so we don't have to do that. Okay. So we're going to do import at OpenZeppelin /contracts/token/ERC721. Now I'm going to do an extensions ERC721 URI storage .sol, because this extension has a couple other functions that make it really nice to work with NFTs. But essentially, it's just an ERC721 extension. Did I spell that right? But it just gives us some extra functions, and you'll see. Okay, cool. Now, to inherit it, we just say is ERC721 URI storage, like so. Now what we can do in our constructor is we can add ERC721. We can add the ERC721's constructor in here, and which takes a name. So we'll say random IPFS NFT RAM. So now our NFT is going to be called random IPFS NFT, and the token symbol is going to be RAN. Okay, great. So what do we want this token to be able to do? What do we want this token to be able to do? Well, we're going to want to be able to mint a token, mint a puppy. Mint a puppy. And that's pretty much it. We're going to want to mint a puppy. And then, actually, I said before we would have people pay for the puppies too. We're not going to add that in here in the interest of time. But that's pretty much it. We want to be able to mint a random puppy. So to mint a random puppy, guess what we're going to use? If you guessed Chainlink, it means you're really smart. Is that an interface ERC20 URI storage? No, it's not. It's the actual contract, because we want to inherit all the functions, right? And if we just did the interface doesn't have the functions defined. Got to lighten your day somehow. Yeah, appreciate it, everybody. Do you know when the video will be available? It'll be available immediately afterwards. Immediately afterwards. Okay. So we need to mint a random puppy. And to do that, we're going to get Chainlink VRF to get a random number. And if you haven't worked with Chainlink VRF, go watch that introduction to Chainlink bit, which walks you through this, right? So because this is what we're going to be implementing. We need to request a puppy. And then on the fulfill, that's when we actually will mint our puppy. Okay. So let's go back here, because I got to be really we got an hour and a half, and I got to put in a lot of variables here. So to mint a random puppy, we're going to do function request doggy. This will be a public function, and we'll have it return a UN256 request ID. Now, in the repo associated with this, we have a fee. So we say like if message.value is less than the fee, revert, but we're going to skip that. Now, to request a doggy, what do we need to do? To request a random number, we need a random number to mint one of our dogs. We gotta do this. We're gonna do coordinator.request random words, and we got to make a request to a Chainlink node here. So that means we got to add all these parameters in here. And where are we going to add those in? If you guessed the constructor, you guessed right. So to work with this, what do we need? Well, we're going to need a VRF coordinator. And we're going to need to store these as storage variables or constant variables in the bytecode or immutable variables. So we'll say address VRF coordinator v2. And here we're going to create a variable up here called VRF coordinator v2 interface immutable I_VRF coordinator. And since we need to interact with the Chainlink VRF coordinator, we're going to need to import the coordinator as well. And if we scroll up in here, we can grab that as well. So we can just copy paste it if you're in the documentation at Chainlink/contracts src v0.8 interfaces VRF coordinator v2 interface.sol, because we need to request a random number from this contract. So we need the interface in order to request the number. We also need this VRF consumer base because it's got some of the functionality defined to interact with the Chainlink VRF. So import at Chainlink/contracts, src v0.8, VRF consumer base. So our random IPFS is the storage thing, and it's also VRF consumer base. So it's both of these. Okay. And again, if you hadn't watched everything Chainlink, you definitely want to watch that as well. But yeah, hopefully you're all having fun. Hopefully you're all learning as we go along with this. Right, we're going to mint some random doggies here that are going to be hosted decentralized. So we need VRF coordinator v2 interface is I VRF coordinator, and the reason we do this I underscore here is just to remind us as developers that this is an immutable variable and it's cheap to work with. Immutable variables are very gas inexpensive. Yes, so why did you put immutable? Great question. The reason we put immutable is because we are going to define this VRF coordinator v2 interface, or this I VRF coordinator variable one time and then never again. And because we're only going to assign this a value once, it is very cheap for us to read from. So we're going to say I VRF coordinator v2 interface. I VRF coordinator equals VRF coordinator v2 interface at address VRF coordinator v2. And if you've been to a couple of the workshops, we know that an interface plus an address equals a contract. So now I VRF coordinator is a contract that we can interact with. Okay, cool. What else do we need? So let's go back to that request here. We're gonna need a key hash. Okay, cool. Let's add that to our constructor. We'll do comma, bytes 32, key hash. I'm actually going to call it gas lane though, because this key hash represents a gas lane, or how quickly we want to send our transactions, basically. So I'm going to use gas lane, and then in our constructor, we're going to say I underscore gas lane equals gas lane, and then up here we're going to do bytes 32 immutable gas lane, like this. Excuse me, I underscore gas lane. Boom. Then what? What else do we need? We need a subscription ID. Okay, let's pass that in as well. Gas lane, I underscore subscription ID. Excuse me, subscription ID. Uint64 subscription ID. And a lot of this is just boilerplate. We'll do I underscore subscription ID equals subscription ID. We'll make another immutable variable. This will be a Uint64 of I underscore subscription. Look at how fast we're going. Hopefully y'all follow along. Well, what's gas lane? Whoa, what are you talking? What is this gas lane thing? Good question. So in here, contract addresses. Each one of these Chainlink VRFs has this thing called a gas lane, or which comes with a key hash, which just tells us like how much gas is max for getting a random number. And the reason that we want this, the reason that we have this is we're saying, hey, if gas is more than 500 Gwei, forget about it. We don't want it. So that's what the gas lane does. It allows us to kind of cap out how much we're going to pay for this. And why are we using bytes 32? Because bytes 32 is gas lane. So this is this layer 1 minting, right? Our layer 2 minting is the thing. This is layer 1 minting, but this will work just fine on layer 2. Yes. Okay, great. We need a subscription ID. The subscription ID, you'll see in a little bit. I'm not going to explain it quite yet, but you'll see soon. What else do we need? Request confirmations. For request confirmations is how many additional blocks need to be added on top in order to consider it a completed, and that's going to be Uint16. We're going to make this a constant variable called request confirmations equals 3. And when you create a constant variable, normally you just make it all caps with underscores. And you do constant variables in the global scope. So I couldn't do request confirmations equals 7 down here because it's a constant. You can't change it once it's been set. Great. So we have request confirmations. What else do we need? Callback gas limit. Okay, let's add that to our constructor. Let's do callback gas limit. This is the gas limit callback back, and this is going to be a uint 32 callback gas limit. We'll say I underscore callback gas limit equals callback gas limit. And then we'll do uint, what did we say was 32? 32, immutable, I underscore callback gas limit. Like so. Boom. What else do we need? We need number of words. We're going to make this a constant as well. This is going to be a uint 32 instead. We're going to say num words equals 1. And this is the number of random numbers that we want to get. We only want to get one random number per puppy called. Is that it? Is that all we need? We got the coordinator, got the subscription, got the gas lane, callback gas limit. The only thing we're going to need after this is dog token URIs, but we'll talk about that in a bit. And the other thing that we have to do in our constructor is we have to give that VRF coordinator to the constructor of the VRF2 consumer base. We'll stick that in here like so. And boom. Constructor set up. We have a whole bunch of variables. We can finally call coordinator.request random words. So in our request random doggy or request doggy, we're going to say request ID equals I underscore VRF coordinator dot request random words. I'm going to pass it the gas lane. I'm going to pass it the subscription ID. We're going to pass it the request confirmations, I callback gas limit, and the number of words. And just checking in with y'all. I know we did a lot of setup right there. Hopefully you're all doing well. Hopefully you're all enjoying it. We're about to do some really cool stuff. All right, back to the code. What does I callback gas limit do? So this is going to be the call. So when we request a random number, we send a request to a Chainlink node. And in a callback function, we're going to define soon, that is how we actually get the random number. So in a second transaction, the Chainlink node is going to respond with our verifiably random number. And we want to say, hey, if the gas is this much, just don't. We're going to give it an upper limit. If it's too expensive to do the callback, don't do it. Why do we want a gas lane and a gas limit? Isn't the gas lane the gas limit? Great question. So the gas lane is going to be the price per gas, and the gas limit is going to be the max gas amount. So let's say our callback function takes 100 gas at 200 gwei per gas. Right? So we have the price per gas is going to be the 200 gwei per gas, and the gas limit is going to be for the 100 gas. Really good questions. What is the uint 64 and uint 32, and when to use them? Uint 64 and uint 32 are just numbers that are smaller, that can't be as big as like as a uint 256, basically. Uint 8 versus uint 16 goes up by increments by 8. Send you a little doc here. Slowly docs. Integers. Right here. Boom. Post that in the chat here. All this VRF coordinator V2 stuff still doesn't work on Polygon, right? We're still using V1 and fulfill randomness. Yes. So right now, VRF V2 is still being rolled out on Polygon. V1. Okay, great. So we have a request doggy. This is how we're sending the request. We now need to fulfill the random number. Once we get that random number, we need to fulfill it. So we're going to create a new function down here where we're actually going to mint the random doggy called function fulfill random words. And this is the function that the Chainlink node is going to call once it gets our random number. So it's going to get our random number, then it's going to call fulfill random words in its second transaction that it responds to. And this is going to be an internal override function because technically the Chainlink node is going to call some other function that we inherit in the VRF consumer base V2. And then that contract will call this function. If that's confusing, don't worry about it for now. Just know that it's going to call fulfill random words back. And it's going to take a uint256 request ID and a uint256 array memory of random words. So it's going to give back an array of random words. Now, in order to mint our token, we're going to call a mint function that OpenZeppelin has, right? So if we look at OpenZeppelin, contracts, token, ERC721, ERC721.sol, mint. Mint. We're going to call this safe mint function, which calls safe mint, which calls mint. Isn't that fun? Mint, which calls mint. What this and all this mint function is doing when we mint an NFT is we just say, hey, the balance of whoever has it gets plus by 1, right? And the owner of that token is going to be whoever minted it. That's really it. So that's all we're really doing when we're minting. We're just assigning ownership to some mapping. So in order to assign that ownership, we're going to need the owner of the dog. We're going to need the owner of the dog, right? The owner who called request doggy. Now, since this is a second transaction, we need some way for us to tell, hey, so-and-so called request doggy. And the way we can do that is we can create a mapping here. We'll call it s_request ID to sender of request ID equals message.sender. And we'll create this mapping at the top. Say a mapping of uint256 to address of request ID to sender. So in fulfill random words, it passes the request ID. When we call the Chainlink node, it gives us the request ID. So if we match the request IDs up, we can get the owner, we can get whoever called this request doggy function. So we're going to say address dog owner equals s request ID to sender, like so. Boom. Now, in order to mint, we're going to have to assign this NFT a token ID. Oh, we're going to need to keep track of how many of these we've actually minted. So once again, at the top, we'll do a uint256 s_token counter. And in our constructor, just to be explicit, we'll initialize it to 0. And we can say uint256 new token ID equals s token counter. And then we'll do s token counter equals s token counter plus 1. So the next token will get its own unique new token ID. Okay. Now, what else did we say we wanted to do? Well, we wanted to mint these dogs. So we can then call safe mint dog owner and new token ID. And technically, this has minted us the NFT just like that, right? Just like that. Oh, a couple questions here. Will we ever get V2 payment subscriptions with other Oracle requests? Is that in the future development pipeline? Good question. It's being discussed. Really good question because a lot of people like it. Good question. I love what the Chainlink community has become. We are all really, yes, excellent. We definitely are. Hopefully you do try this over the weekend. So technically, this is all we would need. But what has this not done for us? Did we get a random dog? Is the Saint Bernard super random? And the answer right now is no. So we need to fix that, right? So we need to add that token URI to this NFT to tell our contract what it looks like, okay? So we need to do two things. We need to do the token URI bit. And then we also need to make the Saint Bernard super random. Now, in order to tell the contract what this dog actually looks like, well, first we're going to need to what? We're going to need to get the breed, right? What breed is this random dog? What breed did we get? But to do that, we're going to create a new function called get chance array. And this is going to be a public pure function, and it's going to return a uint256 of size 3 memory. And all it's going to do is it's going to return 10, 30, and then 100, or I'm going to call it max chance value. At the top, we're going to do uint256 constant max chance value equals 100. And the way that we're going to use this array is we're going to get a random number. And if we say if the random number is between 0 and 9, it's going to equal a St. Bernard. If it's between 10 and 29, it's going to be a pug, because that was the second most voted for thing. And then if it's between 30 and 99, it's going to be a Shiba Inu. So this chance array is going to represent the randomness of our puppies. It's going to represent the randomness of our puppies here. And we can use this get chance array in a new function, function misspelt. Thank you. Appreciate that. In a function called function get breed from modded RNG. We'll take a uint256 modded RNG, and I'll explain what this does in a minute. What we want to do in this random words array, we got a random number. Okay. So we're gonna mod, but this random number could be like something like this. Or excuse me, not like that. It could be something like this. No hyphen. It could be this massive, massive number. So we're going to use the modulo function to get the remainder. If you're unfamiliar with modular or modulo, I always say it wrong. Modulo function. Look, yeah, you can look up the modulo function. But basically, if I pull up calculator, if we did like 2, actually, does this have a modulo function? I don't think it does. If we do 10 divided by 100, we get 0.1. So there's a remainder of 10. So 10 mod 100 would be 10. If we do 110 divided by 100, we get 1.1. The remainder is still 10. So the modulo function gets us the remainder of what doesn't divide evenly. So for example, 2 mod 3 would get 2. 4 mod 3 would get 1, right? Because there's 1 left over when we do the division. So we're going to do this modulo function to get a range that we're looking for. We're going to do mod 100, okay? We're going to say uint256 modded RNG equals random words at index 0, since we're only getting 1 random word because we're saying num words equals 1. Random words at index 0 mod our max chance value, get some modded number, right? And this modded RNG is now going to be between what? It's going to be between 0 and 99, which is what we want. Now that we have this modded RNG, we can use this to mix with our chance array to figure out which breed we're going to get at. To figure out which breed we are going to get. I'm going to go a little bit quicker here because this is a little bit mathy. So, oh yeah, whoa, this constants, more gas efficient stuff? Yes, great question. Yes. So constants are even more gas efficient than immutables because we set them right at the top, right? We set them in this global state. Immutables, we can only make immutable because we set them in the constructor. Constants, you can't set in the constructor. You can only set them up here. And that's why they're so gas efficient. Okay, anyway, so I'm going to do some math here to get the get breed from modded RNG. If this part is a little confusing, you can just come back to it later, okay? Well, basically, we're going to do a uint256 cumulative sum equals 0. And we're going to do uint256 array of size 3, memory chance array equals get chance array. And what we're going to do is we're going to say for uint256 I equals 0. I is less than chance array dot length. Do a simple for loop, I plus plus. And we're going to say if modded RNG is greater than or equal to the cum cumulative sum, and the modded RNG is less than the cumulative sum plus chance array I, then we're going to return I. And then outside of this, if we're going to say cumulative sum equals cumulative sum plus, am I spelling chance array wrong? Chance array of I. And we're going to have this return public pure returns uint 256. Oh, sorry. Thank you. Sorry about that. Great. So we're going to return a number. Now in the repo, I use an enum for the sake of time. We're not going to do an enum, but basically we're going to say 0 equals Saint Bernard. 1 is going to be the pug, and 2 is going to be Shiba. So we're going to loop through that array, and we're going to say, okay, if this returns 0, Saint Bernard, 1 is pug, 2 is Shiba Inu. But now we have a way to get the breed from the modded RNG. So we can say uint 256 breed equals get a breed from modded RNG, pass the modded RNG. Great. So now we have the breed. Now that we have the breed from that random number, we can mint it, and then we can also set the token URI. Okay, we can set the token URI of the dog here. Now I already have my IPFS, these puppies in here, right? And this is going to be an example of where the art is actually created beforehand, and we just pick from one of those NFTs. So in our constructor, we're actually going to pass a list. We're going to pass a list of those dog token URIs, right? So if we go to, I think it's in puppies, might be. So here we go. So we're going to pass a list of these JSON objects, which have, adorable pug, and this is pointing to HTTP IPFS file. This is pointing to the gateway for IPFS, which is obviously centralized, which isn't great. But for the sake of this demo, this is what we're going to work with. Just because some people don't have like IPFS built onto their browsers. So this is a demo. However, if you're doing this for real, you would want to do obviously something like IPFS .. and then the hash. And then I'll show you how to do this IPFS stuff, and I'll talk about IPFS stuff in a little bit. All right, cool. So we're going to pass a string array of size 3, memory dog token URIs. And then we're going to save that to a storage variable. So we're going to say string array of size 3, s underscore dog token URIs. I make this immutable too, but we're not going to, just in case we want to change stuff later. We'll say s dog token URIs equals dog token URIs. Now, what we do here, we're going to set the token URI, and what we're going to say is we're going to do underscore set token URI. And normally you can't call this function. The reason you can call this function is because we're using this extension here. Normally there's some other ways to get the token URI, and we'll go into that tomorrow in our next NFT session. But for now, we're going to do it like this. So we'll set the token URI of new token ID to s underscore dog token URIs of breed. So we're going to pass in a list of these dog token URIs where the 0th index is going to be Saint Bernard. First index is going to be a pug. And the second index is going to be a Shiba. Oh, can't put comments there. Put them there. So that's what this is going to look like. So the 0th index of this dog token URI's list is going to be this, but for Saint Bernard instead. Okay, so we set the token URI, we've minted the NFT, we've gotten the random breed. This looks pretty good to me. This looks really good. This looks like a pretty solid contract. Now we're not doing any events, and I didn't do a whole lot of security stuff, but for the most part, this looks pretty good. So let's do yarn hardhead compile. See if this compiles. It probably doesn't. Right? We need to add Open Zeppelin. So we'll do yarn add --dev Zeppelin contracts. And while this is adding, and then we also need to add Chainlink yarn add --dev at Chainlink/contracts. Okay, great. I joined a little late, so I don't know if this was addressed, but is there a limit on how much one contract can mint NFTs with different specified values and at what latency? Thank you for the awesome tutorial. No, you can do as much as you want. What if we have 10K images? Shall we do the same? Yes. Yep. Are the prefixes S underscore and I underscore a common practice in naming variable? Is there any resources on naming conventions in Solidity? Yes, that's a really good question. So there is Solidity guidelines, style guide, which is really good. I'll post this in the chat here. And this is really good. It doesn't have the S underscore and I underscore naming conventions. That is a Chainlink Labs special. But it's something that I think is really good, and I think more people should use it. So that is how that works. Really good questions here. And I'm going to make all these public in the code base. I made these all private with getter functions, but since we're just doing a tutorial here, we're just going to make everything public. Public. Okay, great. Cool. So now let's try to compile this. And it actually compiled. Wow, that's pretty good. Unnamed return variable can rename unassigned and explicit return to all non-reverts. So we're returning U256. And then we can just say like else, like revert range out of, actually, no, it's not important. Whatever. This is just a demo. Okay, cool. So it compiled. Awesome. We have an NFT contract that is actually compiling. We have a way for it to get a random number and do all that stuff. Now what we want to do is we're going to want to deploy this. We're going to want to deploy this bad Larry. Now, in the code associated with this, this demo, we do a lot of different stuff, right? Because we're doing 3 different types of contracts. We're just going to focus on this one here. Now, if you look in this one, though, there's a lot of extra stuff that we're not going to do. And the reason that we're not going to do this is because, actually, no, we are going to do this. I take it back. I'm just trying to be time conscientious here. We are going to do this. How are we doing, by the way? It looks like my quality dropped again. How is everybody? Are people following along? Is this making sense? Are people like, this is the best tutorial I've ever seen? Or are people like, hey, you know what? NFTs are kind of confusing. How are we doing here? We've been going for an hour solid. Got another hour left, and I'm excited because my quality is freaking going down. So just kidding. I'm not excited about that. That makes me less excited. In fact, that makes me not excited. If one could be so bold. Everything's amazing. Wow. High praise. Very high praise. Quality, but follow along and solid. Okay, great. Does my question on Superfluid apply? I missed it. I did not see it. It's very fast. I know I'm going very fast. If you want to rewatch this, you can slow me down and follow along with the code as well. And I know I'm going really fast because we are trying to get through a lot. I'm trying to show you a lot of stuff here. And if you think it's too fast, please put that in the feedback form, which again, that's posted in the chat somewhere. I forget where it's posted in the chat. It's posted in the chat somewhere. I'll post it again pretty soon. So cool. Well, glad you're doing well. Let's jump back in. That's your breather. That's your breather for this crazy fast workshop here. All right, but this is an awesome workshop. So let's create a new folder. Call this our deploy folder. Create a new file, and we'll do o1 deploy random nft.js. So now we're going to deploy a random NFT. And there's going to be a lot of stuff to do here. Okay. Now, in the code associated with this, I'm actually going to show you it. So you go to the scripts, or excuse me, the utils section. There's an upload to Pinata, which has a script that we can use to upload our code to Pinata. We can upload our IPFS images to Pinata. We can also upload them to NFT storage. And I will talk about these in a little bit, but we are not going to do them. They're very cool. They're very awesome, but we're not going to do them. Anyways, let's write our deploy function here. Okay. So if you haven't worked with hard hat deploy before, we got to go over to our config. We got to add some stuff. We're going to do require hard hat deploy. We're also going to do in our module.exports, we're going to add a section in here called named accounts. We're going to add a deployer, which will be defaulted to 0, which means that our deployer named account will always be at index 0, which is really helpful. Do we need to add anything else for that? If you're going to be working with a .env, you need to add .env. And I'm going to add some formatting stuff in here. You don't have to add the formatting stuff, but you see how it just like changed formatting? I added some formatting files. You don't have to do that. But that looks pretty good to me. Okay, cool. All right, great. So to work with hard hat deploy, we're going to write our deploy script. So we'll say module.exports because we're going to export this. And this is going to be an async function. And it's going to take the hard hat runtime environment as an input parameter. Now, if you look at the deploy scripts in here, it looks a little bit different. It's going to be like, what the heck is this? So in JavaScript, you can actually pull out variables out of the HRE right in the parameters, which is kind of weird, but cool. So doing it like this is going to be the exact same as saying HRE. And then in here, doing const get named accounts, comma deployments equals HRE. I know JavaScript's wild, but that's what that does. So I'll just do it like that here, but it's the same in here. They do the same thing. Question, Patrick, I would love to see some integrations with Superfluid. Not now, but if there is some chance in the future, it would be awesome. Please. Agreed. Yeah, Superfluid along with royalties from Open Zeppelin and some Flashland stuff in the middle. Yes, that would be cool. Unfortunately, we'll not get to that here. So we're going to say const deployer equals await get named accounts. And this is going to get our deployer address, deployer account. We're going to say const deploy comma log equals deployments. This is going to be our deploy function we're getting from this deployments thing, which comes from the hard hat deploy. And we're also going to say const chain ID equals network.config.chain ID. And since we're going to grab this network thing, we're going to do const network equals require hard hat. So we're going to grab network. You'll see why we need the chain ID in a second. And to get the chain ID to work in our hard hat config, we're going to need to add a networks tag. So we're going to say networks. And for all of our networks, we're going to just have to give them their chain ID. So for hard hat, the chain ID is going to be 31337. And then we're also going to use rinkb. I'm going to come here. Rinkb, where the chain ID is going to be 4. So we're going to use hard hat and rinkb for this. So we need chain ID, great. And the reason we need those, you'll see in just a second. And then we're going to need some addresses. We're going to need the VRF coordinator v2 address and the subscription ID. Okay. Now, the reason that we need these two chain IDs and we need the network stuff is because if we're working on a regular chain, I'll write this here. If we are working on a test net or a mainnet, are these addresses, is the VRF coordinator v2 address going to exist? Yes, those addresses will exist. Otherwise, on a local chain, they won't. We need to do something called mocking. So we're going to say if our chain ID equals 31337. So if we're on a local chain, then we're going to make a fake Chainlink VRF node. Otherwise, we're going to use the real ones. This is a concept called mocking, and it's really important to what we're doing. And this needs to be double equals, not single equals. Because our local hard hat nodes will have no idea what a Chainlink VRF address is. No idea. So we need to go ahead and make it. And the way that we typically do that is we create a new folder in here called test. We typically will put our mocks in here. So we're going to create a new file. We're going to call it VRF coordinator v2 mock.sol. And lucky for us, the Chainlink GitHub repo already has one. So we can just do spdx license identifier MIT, and then pragma solidity 0.8.7. And then we just say import at Chainlink /contracts /src /v0.8 /mocks /vrf coordinator v2 mock.sol. Boom. And now this VRF v2 coordinator mock is this import right here, which is great. So now that we have that, we want to say, okay, if we're on a local chain, use that mock, otherwise use the real one. So before we can actually deploy our random NFT, if we're on a local chain, we're going to need to deploy those mocks. So we create a new file, 00 deploy mocks.js to do exactly that. And a lot of this is going to look the same. So I'm going to copy all of this boilerplate here. Boom. Because the startup of this is going to be exactly the same. And then we're just going to say if chain ID equals 31327. Then we're going to do await deploy. And this is how you do deploy. This is how you deploy contracts with hard hat deploy. We just say the name of the contract, VRF coordinator v2 mock, comma. And then we add the parameters. So we're going to say from deployer. Log is going to be true. The args are going to be, and this is where we get the parameters for the VRF coordinator v2 mock. I'm just going to copy paste them because it's not really important for the demo here. If you want to go back and figure out what these are or ask questions later on, you can. But let's kind of breeze past it for now, just in the interest of time. And then we'll do at the bottom module.exports.tags equals all and mocks. Cool. So this is how we're actually going to deploy our mock, our fake VRF coordinator v2. And now we can use it in here. So what we're going to say is to use the fake one, we're going to say const VRF coordinator v2 mock equals await ethers.get contract VRF coordinator v2 mock. Like that. And now you can say the address is going to be, you could say VRF coordinator v2 address equals that mock dot address. Great. Now, if you haven't seen that everything Chainlink and you haven't worked with a VRF coordinator v2 mock before, you definitely should after this video. It will teach you a ton. But whenever we work with a VRF coordinator, we actually create a subscription to work with it. So one of the first things we're going to do is we're going to say const tx or transaction equals await VRF coordinator v2 mock dot create subscription. Then we say const tx receipt equals await tx.wait for one block. So we create this transaction called create subscription. So we're creating a subscription. We're creating a way for us to interact with this VRF coordinator contract. Now we're waiting a single block. And the reason we're waiting a single block is because we're going to get a subscription ID from the transaction receipt events. Events 0.args.sub ID. And if we go into VRF coordinator v2 mock code, a function creates subscription, and it emits this subscription created event with first argument being a sub ID. So that's all we're doing here. We're getting that sub ID from the event that was emitted from this create subscription transaction. And the reason we need this, subscription. The reason we did this is because then we need to fund the subscription. So we'll say, and this is where you would fund it with like Chainlink token. On a mock network, we're just going to fund it with kind of fake nothingness because it's just a mock. But I'm going to say await VRF coordinator v2 mock.fund subscription. We're going to pass the subscription ID and some fund amount. So, and this can be whatever we want. For us, we'll just say const fund amount equals, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll just say that, but it doesn't really matter. On subscription. Okay, great. Now, if we're not on a local chain, what are we going to do? Well, we're going to use the real contract addresses. We're not going to use a fake one. We're going to use a real one. So we're going to say VRF coordinator v2 address. And since we're just going to use Rinkeby, I'm going to go ahead and hard code it in here. But if you look at the deploy scripts, we actually get it from a network config object. So we get it from another file. But since this is just a demo, we're going to just automatically do Rinkeby. And we can find those in contract addresses. Look for Rinkeby testnet. And great. So the VRF coordinator v2 address is going to be this one right here. Set in here. And then our subscription ID is going to be something that we make, right? So we do need to make a subscription ID. And the way we do that, we can go to vrf.chain.link and we can create our own brand new subscription. Now, first we connect our wallet to our MetaMask to create a subscription. And you can do this programmatically as well. Oh my goodness. Sorry, 1 second here. Let me just there we go. And I got to put in my crappy password because this is my demo profile. Come on, crappy password. Okay, cool. Now we can go back. And we could switch to Rinkeby. And we'll switch to an actual account here. Okay, cool. So we have a little bit of ETH in here. If you need ETH, you can go to faucets.chain.link, go to Rinkeby, get some test on Ethereum to be good to go. But we're going to create a new subscription on Rinkeby. So we're going to connect our wallet to do that. Now that we're actually up, we're going to hit create subscription. Please approve subscription creation. We're going to go ahead and approve this on our test account. And what we're going to do is we're creating a subscription, which is going to give us a subscription ID here. And we're very close to having our puppies on OpenSea, to having our puppies in real life. And while this is indexing, while this is going through, does it actually give us our... no, it doesn't give us our events. Once this finishes, we'll have... oh, great. We have one already. Now we can add some funds. I have some link in here already. We're going to add 20 or 10 is probably fine. We'll do 15. Again, you can get testnet link from faucet.chain.link. We'll confirm. And cool. And we're adding some funds to our subscription. And this is subscription-based methodology is how we can get our random numbers. But we just need that subscription ID. Cool. So now we're going to add consumers, or I'll do it later. We now have this ID of 3491. What I can do is I can say subscription ID equals 3491. Perfect. Now that we have all this stuff, we finally can actually deploy our NFT. So we're going to say args, and this is where we're going to pass our constructor arguments, which is going to be BRF coordinator address. It's going to be the subscription ID, subscription ID. We need to pass in the gas lane, mint fee, and callback gas limit. Now we're just going to hard code everything with the Rinkby one, because even if we're doing it on a local chain, doesn't matter. Contract addresses, docs.chain to link, Rinkby. So this is the gas lane, and let's just check what comes actually. Coordinator, oh, gas lane is actually next. So we'll do gas lane after gas lane. Subscription ID, okay, that's subscription ID. Callback gas limit. That can kind of be whatever we want to do. So we'll say 500,000 gas. 500,000 gas. And then we need the dog token URIs. Okay. Now, like I said, because we don't have time to actually show you creating, like uploading the metadata to Pinata, let's talk about kind of working with IPFS and the pros and cons of IPFS. So go to IPFS, got this website here. IPFS is a peer-to-peer hypermedia protocol designed to preserve and grow humanity and, blah, 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 right? So IPFS is really cool. Now, I made some really nice pictures here. To kind of show a little bit more about IPFS. Oh God, that does not look nice at all. Hold on 1 second. Let me get a nicer version. Second. And we're almost done. We almost have these. We almost have these on chain. For those of you who are still here, you're all amazing. Absolutely amazing. So what we're going to do, where is it? Image. Do it like this. There we go. Yeah, that doesn't look that much better, but we're rolling with it. Can I do it like this? Will this look better? It's kind of gross, but hopefully you can see this okay. So IPFS is this system where all of our code gets hashed, right? All of our code, all of our files, any image gets hashed into this IPFS : / and then this hash here. And then we can pin it to our node. Now, in order for it to stay persistent, other nodes have to pin it. So IPFS is a distributed, decentralized application, but it's not a blockchain. It doesn't produce blocks. It doesn't have any computation. It just stores data. The only way for it to really be decentralized, though, only way for your data to really be decentralized is if other nodes pin it, right? Other nodes have the option to pin your data. The difference is, yeah, PNGs and their transparent backgrounds, agreed. The difference between IPFS and a blockchain is that another blockchain is going to always have everything, right? It's going to add blocks, it's going to save all that data. IPFS, it's optional for the node operators how much data they want to have. So I could have an IPFS node that's 1 kilobyte large, and I can have an IPFS node that's 50 terabytes. Your IPFS node is whatever size you want it to be. So it's more decentralized because other nodes can easily pin it and keep it kind of in this distributed setup. But you've got to keep that in mind when you're looking at these. So one of the sponsors for this hackathon is actually Filecoin. And what Filecoin does, what Filecoin can do, is Filecoin can actually pin your IPFS data for you in a blockchain sense, in a provably deterministic sense, and a provably verifiable sense. So that's kind of where Filecoin and IPFS kind of match up. IPFS nodes don't have to pin your data. Filecoin nodes will pin your data in a deterministic fashion. So that's why Filecoin is so powerful. But IPFS at least has the ability for us to pin data, have other people pin the data, and it's not just some centralized server. Because if it's just a centralized server, that server goes down, it's gone forever. If your IPFS node goes down and another person has it, then it's fine. Then life can continue. So that's why IPFS is so preferable to, a centralized server. So we need this list of dogs. So I have gone ahead and I've already created those JSON files and uploaded them to IPFS. So I'm going to do a little cheaty stuff here. Let token URIs equals like this. Each one of these token URIs are going to represent a dog. So the first one's a pug. So we got to switch this one to number 2. And I think this one's a Shib, right? Shib NU. So we got to make that one number 3. Right. And the reason we're doing that is so that our randomness works. So St. Bernard, Pug, Shiba Inu. And these are IPFS hashes for those JSON bits, right? And if we go back to them, we also have IPFS hashes for what the images look like. So end to end, and these actually, so I lied. These ones are using IPFS hashes. So it is end to end, using IPFS, which is awesome. But if you don't have these, again, be sure to check out the script that we wrote in here. This utils upload to Pinata. Pinata is a service that can also pin your data. So if your node, if you don't want to be the only one to pin your data, Pinata can help pin for you. So Pinata is what's known as a pinning service. Now NFT.storage is kind of like a Pinata, but it also hooks into Filecoin. And so it'll pin your data to IPFS and then also on Filecoin so that it is, decentralized in a deterministic way. But cool. So now we have these token URIs. And like I said, those scripts would show you how to upload them and save the files and everything. And we also see kind of in the deploy here, we have a metadata template. So it even in the scripts here, we even have a way to create those metadata templates. But we're going to skip all that. I'm sorry. And we're just going to use the ones that we have. Okay. So for the list of dogs, we're going to do token URIs, just like that. We do not have time, unfortunately. Now that we have the args, we can do const random IPFS NFT equals await deploy. Deploy, and then we're right here. Random IPFS NFT, comma, from deployer. Let me scroll down a little bit. From deployer, args is going to be args, and log is going to be true. And then in the code, I also have a way to auto verify, but we're going to skip that as well. And then that's it. So we've written some deploy stuff. We've written the actual smart contracts. Now we would typically write some tests, but we're just gonna mint these bad Larrys, and we're gonna see if they work. Right? We're gonna mint these bad Larrys and see if they work. After we mint them on vref.chain.link, if we're actually on Rinkeby, we're going to have to add a consumer to this to tell the Chainlink VRF node that that NFT contract is cool to mint stuff. But let's go ahead. We'll try to mint this, and then actually we'll do full.log.address right there. So let's try to deploy this to our local host first. So to deploy, we'll do yarn hard hat deploy like this. Oh, and actually, we can't deploy to Rinkeby because we don't have any stuff in here. We haven't told hard hat how to actually connect to the Rinkeby chain. So for URL, we're going to add process.env.rinkeby rpc URL. So we're getting an environment variable, but this is just going to be like an Alchemy RPC URL, which if you got this hackathon, you're getting 2 free months of their growth tier. So we stick in an RPC URL in here. Chain ID, it's going to be, I already have that. And then we also need the accounts in here. We don't need it for our local hard hat because hard hat gives us some accounts, but we need accounts down here. And this is just to be a list of process.env.private key. And even though this is a burner private key, I'm still going to close my video when I run it. But we're going to run hard hat deploy just to see if this works on a local network. I ran into an issue. That needs a semicolon. Let's try again. Okay, compiled successfully. Ran into another issue. Can I read properties of undefined get contract? Wait, ethers.get contract. And that's because ethers. Ethers? Spell it wrong? 9 times out of 10, I usually just spell stuff wrong. No, I didn't spell it wrong. Can I read properties of reading get contracts? So it's having a hard time finding ethers. Oops. I'm getting ethers from Hardhat. Am I getting ethers from Hardhat? I'm not getting ethers from Hardhat. Where am I getting ethers from? Getting it from HRE? Is it HRE.ethers? I think it's HRE.ethers. So not from that either. Get contract. Config. Hardhat deploy. Do I need this? Doesn't make any sense. Hardhat ethers. Ah, yes. You are correct. I do need hardhat ethers. Yes. Good call. Ethers. Yes. Okay. Yep. You're right. So this imports hardhat ethers, so that should work. Thank you. And I spelt. All right. Cool. Yes. Thank you. That was perfect. I spelled random IPFS NFT wrong. Lowercase. One more time. This is why we do stuff locally first, right? So when we bunk it up, big shout out to you on that. Excellent. Thank you. All right, cool. So now it's working locally. We can see it actually deployed, and there it is. So, moment of truth. We're going to deploy this to Rinkeby. And so we're going to run the same thing, yarn hardhat deploy -- network Rinkeby. I'm going to do it off screen just because even though I'm using some burner accounts, Sometimes the Alchemy URL pops up and it's a burner account, but you never know. So we're deploying right now. I did hardhat deploy -- network rinkb, and we're deploying. Once it deploys, we're going to add that as a consumer, right? Oh, it already deployed. Oh, sick. All right, cool. We're going to come back to the code. Now we have this address. We're going to add this as a consumer to our bit here. We're going to add consumer, paste the address in here, add consumer, approve adding it like so. And we are going to be in good shape. Come on. And I forgot to test minting this. Whoops. So we're going to create a new quick folder called o2 mint.js. Be really, really quick with this. I'm going to copy paste some code here. But basically we're just going to be minting this NFT because I want to have plenty of time for questions and to fiddle around with OpenSea. We're going to do random IPFS equals wait ethers. Const ethers equals require at player again, and there's no mint fee. What do we call it? We call the request doggy. No mint fee, random IPFS deployer. Looks good. Mint. And I should be able to just do yarn hardhat deploy -- tags mint. Once this goes through, and it has gone through, okay, great. So should just be able to do -- tags mint. Let's do compile, and I ran into an error. Deployer is not defined. Well, that makes sense. Grab the deployer here. So all I'm doing is calling request doggy. Hopefully that's what it's called. An error occur. No contract deploy with name random IPFS NFT. Series equals require hard hats. What is it called? It's called random IPFS NFT. Contract called. Oh, it's because I need to be on -- network rinkb. Getting right to it. Need to use rinkb. Yes. Y'all smarter than me. Yes. All right, cool. And we're done. And so we probably ran that function. Now, finally, let's go over to rinkb Etherscan. Let's go to that contract. And we didn't verify it because I didn't want to. And we should have just sent another transaction here. So let me grab this address. We should have just sent another transaction literally half a second ago. So we add consumer. There it is. There's our mint transaction right here. So this is going to request our NFT, right? And then in a second transaction, we're going to get it back, right? And we're going to see that random NFT, right? We're going to see the random NFT. It's going to have everything. So we just have to wait. If we look at our VRF consumer, we hit a little refresh. Nothing has been fulfilled yet. It's because it probably hasn't gone through yet. But if we wait here a little bit, we'll see this consumer be fulfilled because the Chainlink node is going to have returned our random number for our NFT. Carlos loves NFTs. And then as we kind of wait here, as we kind of chill out, we wait for rinkb to run because rinkb can be a little bit slow sometimes. What do we think the dog is going to be? Do we think we're going to luck out? Do we think we're going to get the St. Bernard? Do we think we're going to get the pug? Or are we going to get stuck with the super unrare Shiba Inu? Can we make the user pay the VRF fee? We could. We could do that. That would be a lot more code, and we didn't do that here. But yes, we could absolutely have the user pay. So we could have the user call that fund subscription, right? And it be the one to pay fund. We could have the user call the fund subscription function, have the user pay the fee there. So, and it looks like, go back to code here. It looks like, there was a last fulfillment of this Chainlink VRF bit here. So now if we go back to the contract, we do a little refresh. Look at internal transactions. Oh, there was an internal transaction 50 seconds ago. This is going to be an internal transaction calling that fulfill randomness. So I'm willing to bet if we grab this address, we go to testnets.opensea.io, we paste it in here, bada bing. Oh, we now have a random IPFS NFT version 3. There's one item. It's currently super blank. Let's refresh the metadata, but we can see it on NFT, and then we'll see how long it takes for OpenSea to update. But I just posted the link. We just minted this live to IPFS. We just minted this live to Rinkby, and depending on how quickly OpenSea wants to give us the metadata, we will get to see what we got. Now we could also we could jump into it. We could do yarn hard hat console -- network. We could jump into the console, and here we can actually see random IPFS NFT. We can actually see what we got for a dog token, or excuse me, what breed we got for that token ID. So the token ID is going to be 0. So we'll say const NFT contract equals await ethers.get contract. Paste that in. And now we can see, we can do await NFT contract dot token URI of 0. And boom, that's the token URI. So which one did we get? Which puppy did we get? Oh, we got the Shiba Inu, which makes sense. It's the most common one. Don't stop minting till Bernard. Oh, hold on. All right. And we do a refresh on OpenSea, and now we do see the Shiba Inu. It is a Shiba. So we got a Shiba Inu. Should we not stop minting to Bernard? We should just like keep minting. You guys want to keep minting because now we have a little bit of time. So we can do this again. We can just keep minting until we get a Bernard. Mint, 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 mint. And actually, what we could do, we could update our mint function. And we could just do like, we call this like a couple hundred times, or just a few more times. Actually, we don't need this. Actually, we don't need a lot of this. We can just keep doing this. Ready? We'll just go boom. So we'll call it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll just ship it. We'll just send it. We're gonna mint. We're gonna mint a whole bunch of doggies. Here, and then hopefully we'll have a Shiba Inu. If we go back to the OpenSea collection, as these get minted, as the Chainlink node responds with more and more of these Shiba Inus, we'll get more and more. Now, if we wanted to mint a ton in a row, we could obviously go back to, and we could update our contract here with fulfill random words. With, since we can request a ton of random words, we can get a ton of random dogs, right? Keep minting or add royalties. Okay, all right. Questions though. Would it be safe to generate only one random number with VRF and use the same random number to mint all the tokens if we stored it in a private variable? Great question. And the answer is it depends on your setup. And sorry, I know my quality just dropped again. It depends on your setup. So when, if other people can see what they're going to mint and then adjust their behavior based off of that, then it's not safe, right? However, if that one random number generates all your NFTs in the exact same block, in the exact same transaction, then that's okay, right? Because they can't manipulate it in any way. However, if you say, hey, like we're just going to use that random number as a seed for all these other random numbers moving forward, then that's not fair. Private variables can still be read on chain. Exactly. Yep. Private variables can be read on chain so people can see what your random seed is. And sorry, I know my quality just dropped off a cliff. Can the minting process be part of some flash loan contract logic? Yes, it sure can. Anything can be part of the flash loan contract logic. It absolutely can. Yep. Sorry, I know my quality is falling off a cliff. But now if we refresh this, it looks like we have a whole bunch of dogs coming in, and they're all Shiba Inus, huh? It looks like we haven't really got too lucky. We've just been getting straight Shiba Inus. We have 6 now. Hey, we got a pug! Hey, we got a pug! Look at that. That's pretty cool. Can we get a Saint Bernard? Or are we just going to be stuck with these shibs? And we're still minting here, so we could run this again and just keep minting. Oh, it just finished. All right, let's keep minting. Let's get a Saint Bernard here. Okay, pug, Shiba Inu. Let's do a little refresh metadata. Maybe these are Saint Bernards. Maybe that's why they're not loading, because OpenSea's like, oh my gosh, you got the super rare Saint Bernard. Refresh. No, it looks like we got more Shiba Inus. And you can see, like, this is why kind of adding that rarity is so important and valuable, right? We can actually create true scarcity, true random NFTs by creating that reproduction, by adding that randomness trait. Why would anyone want to create an NFT entirely on chain? Wouldn't that be a lot more expensive? Amazing question. We are going to go over that, I think, tomorrow. It is more expensive, but you don't have to rely on any external decentralized database. And so everything will just be on chain. So if you want to keep your code relatively simple, you can do something like that. Filecoin versus IPFS. Can you give us a breakdown of their differences? Do you have any code snippets for deploying NFTs via Brownie Python? Yes, we do. NFT Mix. Definitely check this out. I just posted it in the chat here. It is a Brownie Python. It is a Brownie repo for deploying and working with NFTs. It is phenomenal. I really like it. Well, I also made it, so you know. Yeah. So Filecoin versus IPFS. So we actually have the Filecoin and IPFS team sponsoring this hackathon, and they are going to give some talks. I think tomorrow they're actually going to give a history of Filecoin and IPFS. So you definitely want to see that one. It's going to be a ton of fun. But basically, the difference is that IPFS doesn't guarantee data persistence. Somebody has to pin your data out of the goodness of their heart, or because you're paying them, or whatever. Filecoin guarantees data persistence, and that's the difference. So Filecoin is a blockchain of hashes of data. Is a blockchain of hashes of data. So Filecoin has data persistence, guaranteed data persistence. IPFS does not. Hopefully that's clear. And let's do a little refresh. Did we get a Saint Bernard yet? Come on, Saint Bernard. Shiba Inu. Hey, we got a Saint Bernard. Woo, we did it. Yeah, Saint Bernard. But as you can see, like, doing something like this, we got a couple. We got 2 Saint Bernards, and we got a ton of Shiba Inus, because there's a 70% chance of getting a Shiba Inu. There's a 10% chance of getting a Saint Bernard, and a 20% chance of a pug. So we actually got 2 Saint Bernards, which is pretty good. All right. Questions. We just went through a ton of code. We did a ton of stuff. We made a really, really cool contract. We deployed it. We saw it on OpenSea. We saw our NFTs come to life, if you will. What other questions do we have here? Reproduction. Yes. NFT contract gets a reentrancy attack. Yes, you could reentrancy attack an NFT contract. If you want, there's a ton of great resources on reentrancy. Solidity, by example, has probably my favorite one. I'll put a link to it in here. Oh, and then before you all go, please take the feedback form. Let me grab that. Said I would have it. Said I would have it closer next time, but I did not. Here we go. Here it is. Please take the feedback form. Let us know if this was good, if this was bad, if you loved this, if you hated this. Yeah, let us know. Let us know. Okay, great. Questions. Filecoin is what enables persistence to IPFS data using crypto economy. Yes, exactly. Tippy, spot on. Shiba. Your awesomeness attribute is 100. I'm flattered. Perfect. I'll be there for Filecoin's presentation. Yeah, it's going to be great. It's going to be really good. I think you got a Bernard. You gosh darn right I did. Or we did. No, this is a we thing. This is a we got a Bernard. Actually, let me do a refresh now on it. Let's see what we have. It's a whole bunch of yeah, if anyone wants to were people refreshing? Is that why they were showing up? But yeah, if anybody wants to see like what we ended up getting, go for it. And anyone should be able to mint actually. If you go to that contract, you call the mint function on it, should be able to mint. Thank you for the kind words. Pinata and Filecoin do the same then? No, really good question. So Filecoin uses blockchain economy, as Tippy said, to guarantee your persistence. Pinata is just a centralized service. So Pinata is like going to your buddy and being like, hey, I'll give you $10 if you pin my data. And that's kind of how that works. So Pinata is a centralized service. Filecoin is a decentralized service. So that's the difference. Good question. Send us those NFTs. I mean, they're on Rinkby. They're not anything special. I mean, if you want, you can go to the contract. You can mint it right now. You can mint right now, right? The mint, the request puppy is has no access controls. What is expected to happen to all the deployed contracts / tokens on testnet blockchains? Demos, tests, mostly garbage. Is it intended to live forever and for free? Really interesting question. Really timely question. Rinkby, Ropsten, Coven are all probably going to die at some point. They're all going to go away at some point. New testnets will come in. So there's no economic incentive for people running testnets to continue to run testnets. So you can be assured that they probably won't, right? That right now, people who are running those nodes are running them out of the goodness of their heart. So they probably won't be up forever. Rinkby is one that will be decommissioned at some point in the near-ish future. So they won't be up forever. Good question. Definitely going to rewatch this. Well, I hope you do, my friend. Yeah, Tippy is the man. What kind of features we can add in our NFT marketplace using Chainlink? Whatever you want, really. Tomorrow we're doing one that's really cool. We're doing a dynamic SVG, or tomorrow or sometime this week, I think, a dynamic SVG NFT where the NFT's image actually changes without you having to spend any gas, changes based off the price of an asset, which is really cool. All right, cool. So we have 10 minutes left. Are there any other questions or any other craziness y'all want to see in the last 10 minutes? I know we went really fast. As you can see, it's because we had to write a lot of code. I wanted to get to the end where I could show you, us actually deploying this to OpenSea, showing these puppies on OpenSea, and kind of really getting you to that aha moment, like, oh, okay, that's what it looks like now on an NFT marketplace, right? And that's how that randomness comes into play, right? Because we saw most of the NFTs we minted were Shiba Inus, which makes sense because they were the most common based off of our chance array that we created. And that's how you can create, very rare traits for characters, for cards, for NFTs, for whatever you want to do. Whatever you want to do. Like doodles, you will store the SVG on chain. Yes. So the SVG section that we do will be an NFT where the metadata is 100% on chain. Really good question. Really good question. Any other thoughts, comments, questions? And then again, remember, please fill out that feedback form. Got the link right here. I think I got a QR code as well. Let me grab this QR code. Let me download it. This is what I should just be doing the whole time, huh? Just the QR code. Switch. Let me show this QR code. So that's the code, the QR code for this. Well, I can't see it because the thing's in the way. So that's the QR code for this section, for this session. Please fill out that form. Would be super, 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 super helpful. Really appreciate that. All right, cool. Any other questions? Was OpenSea exploited recently? I guess define exploited. Maybe. I'm not exactly sure. How does the process of minting NFTs on Polygon versus ETH? It's exactly the same. Exactly the same. The only difference is you notice how we did that, dash dash network Rinkby when we deployed. You would just do dash dash network Polygon or dash dash network ETH. That is it. Other than that, everything that we did is exactly the same. Nearly exactly the same. Sorry. Great question. You will create an auto generator to generate a dynamic SVG. We won't do that, but I do have a YouTube video where we do have an auto generator that generates a dynamic SVG. So the one we're going to do tomorrow, the SVGs we're going to come up with beforehand. But I do have a YouTube video where we do generate a dynamic SVG, which is really cool. How does the process differ? I answered that already. Great question. Alternatives from Wavering Protocol when making an NFT marketplace. I'm not familiar with Wavering Protocol. I'm not familiar with them. Any upcoming news on NFT standards? I mean, there kind of always are. This week in Ethereum, good email thread to follow along with. Cheers. Thank you for your comments as well. CryptoPunks are entirely on chain, right? You want to find out? Are we about to expose CryptoPunks? I'm actually pretty sure CryptoPunks are 100% on chain. CryptoPunks, right? And now you all know how to expose projects for being centralized. I didn't mean to give you that superpower, but I guess I did. Let's check. Let's check CryptoPunks. Why not? Right? We're here. So we'll click a CryptoPunk. We can go to its details. We can go to its contract. And the thing is, if this contract isn't verified, you can still call token ID on it, right? It'll still work even if it's not verified. So let's go find token ID. Or token URI. Oh, there is no token URI function, huh? You'll see this. Oh, it has image hash. Oh, so they do something a little bit different. They do their own image hash things. They're not. It looks like they're actually not following the ERC 721 standard. Oh, that's really interesting. But whoa, that's kind of cool. But it looks like they do it 100% on chain because they do have a hash of what the image looks like, right? So just by them storing this hash, this is a unique identifier of what this CryptoPunk looks like. So they are on chain, but they're using a slightly different standard. Oh, that's really interesting. I didn't know that. Great question. Can data be called using an API and turned into NFT document instead of picture stored on IPFS? Yes, you can do pretty much whatever you want. Good question. What do you think about IMX? From my point of view, Polygon is the best. I'm unfamiliar with IMX. Sorry, I'm unfamiliar with that. Love your Twitter solidity questions, problems. Thank you. I haven't done them in like a week. Tips to make project on NFT marketplace for hackathon, virtual hug. Make it really cool. Use Chainlink, make it really cool. Whatever you want to do something new, do something unique. Or do something that just speaks to you. It's do something that you really like. Yeah, the image is generated. You mentioned in one of your videos that you use a script to automatically write metadata for each minted NFT to a JSON file. Can you point me in the right direction? Yes. So in that repo that I shared, we do that, right? We have that upload to Pinata and upload to NFT.storage. Both of those scripts take an image file, convert it to metadata, and upload it to IPFS. On the NFT mix and the NFT mix video that I did on my YouTube channel, I also show you how to directly send it to IPFS and not Pinata, not NFT.storage, not Filecoin, directly to your own IPFS node. So those are some of the places you can look. You can look at that GitHub repo I shared for this video. You can look at some of my videos on NFTs where I do it with Python as well. Those are some of the places you can look. ERC 721 enumerable metadata and URI storage standards could be remade as interfaces to work together, or they need to be separated from each other. yes, you could put them all together if you wanted to. They don't need to be separated. That's just something Open Zeppelin does to make it more composable for us developers to use. These are really good questions. Really good questions. We got 2 minutes left. Any last questions? Any last questions? Hopefully I'm answering these well. Do y'all like my Powerline t-shirt? Oh, I realize it's like kind of being see-through. Oh, the green screen is picking up on it. Whoops. Whoopsies. I should have worn a different shirt. It's a Goofy movie throwback if you're all familiar with a Goofy movie. Any last questions here? These have been phenomenal questions. It sounds like you all have learned a lot. And unfortunately, we exposed a project, and I exposed myself for having a weak moment with League of Legends. So this has been a great stream. Does IPFS have a testnet? How long is the data available? So IPFS isn't a blockchain, right? So it wouldn't have a testnet. And IPFS, each node is as big as you want it to be. So if you pin a data to your own IPFS node, it'll be there as long as your IPFS node is running. So if you run it forever, it'll be there forever. If other nodes run it forever, it'll be there forever. So the data is as available as long as people have it pinned. And again, the difference between IPFS and Filecoin is IPFS has no built-in monetary incentive to keep IPFS data pinned. So hopefully that makes sense. And no comment. I mean, as a League of Legends player, I can say with assurance that, League of Legends is a horribly addicting game. What do you think about IPNS? I'm a little less familiar with IPNS, so I'd have to get back to you on that. That's also why I swore off IPFS. Now I'm addicted to smart contracts, which I would say is better. Being addicted to stuff isn't great though. Now I love giving talks and teaching y'all how to make crazy weird NFTs. Wild Rift, no good on the phone. Apparently we can change the data a CID points to using IPNS. Oh, that's really cool. But that seems also kind of dangerous. That might be for another conversation. But with that being said, thank you all so much for being here. Let me just pull up one more time the feedback form. Thank you all so much for being here. And this is when my quality drops off, so it's perfect time for me to go. Thank you all so much for being here. Hopefully you all learned a ton. Please take that feedback form. Tomorrow we have an amazing lineup of workshops. So be sure to check hack.chain.link or check your calendar for those workshops. I'm actually pulling it up right now. Tomorrow we have, what do we have tomorrow? Tomorrow we have 100% NFT on chain. It's going to be code along 7 a.m. Eastern. We have Polkadot, Parachains, and Substrate, and they're giving a $75,000 bounty, so be sure to go to that too. Adding play to earn mechanics to a browser-based game with Polygon, and then using Python to become a DeFi quant or a DeFi quantitative. So that's going to be really cool. And then Friday, we're talking front end. We're doing front end. We're doing websites. We're doing full stack applications. So Friday is going to be an absolute blast. So be sure to go to Friday if you're looking to build a full stack application. All right. With that being said, thank you all and good luck at the hackathon. Take care.